Hello everyone, this is Heading Tian. This video, let's learn chapter 12.3, measures of dispersion. The first one, let's learn the range. The range is the difference between the highest and lowest data values in a data set. Indicates the total spread of the data. So the range equals highest data value minus lowest data value. Or I can say the largest number minus the smallest number. So if I have some data like 1, 2, 3, 4, 5. So the range equals the greatest number is 5 minus the smallest one is 1. So I got 4. 4 is the range of this data set. Let's use the formula to see the first example. Let's see the data, the figure. The figure shows the age of 4 oldest US presidents at the start of their first term before 2020. Find the age range for the 4 oldest presidents. Let's see. The oldest president is Trump. He's 70. And then the youngest one in these 4 is 65. So the highest data value is 70 and lowest data value is 65. So the range is 5. Okay, next one, let's see the deviation, the definition of deviation. Deviation from the mean equals data item minus mean. So that's the difference between each data and the mean. So if I still have the same example 1, 2, 3, 1, 2, 3, 4, 5, 2, 3, 4, 5. So what is the mean of these 5 numbers? Mean equals the sum of all of these 5 numbers, 1 plus 2 plus 3 plus 4 plus 5, divided by how many of them? How many numbers? So there are 5. So 1 plus 2 plus 3 plus 4, 10 plus 5 is 15. 15 over 5, that's 3. So the mean of this data set is 3. And the deviation for each items, so I can make a table. I can list them in a table. The first line, I can say that's my data items. So the X represent each of the data. So the first one is 1. Second one is 2. Better 2. 2, 3, 4, 5. And the next line, I say this is deviation. So the deviation equals the data item minus mean. The data item is 1, minus mean is 3. So this is -2. And the next one, 2 minus 3 is -1. So 3 minus 3 is 0. And 4 minus 3 is 1. And 5 minus 3 is 2. So I found all the deviation for each items. So that's the way we find the deviation. So let's see the example. A group of data items and their mean are given. So they provide us the data and also give us the mean. So we don't need to sum up all of these and divide it by the number of the items. So let's see. The first question, find the deviation from the mean for each of the data items. So it's looking for the deviation for each items. That means I can also make a table. So this is number A. So the X, the first one is 30, and then 50, 70, 120, 180, and 270. So the second line is the deviation. Deviation use the data items use 30 minus 120. So 30 minus 120 is -90. 50 minus 120 that's -70. 70 minus 120 is -50. 120 minus 120 is 0. 180 minus 120 is 60. 270 minus 120 is 150. So we solved the number A. How about number B? Find the sum of the deviation in part A. That means I can sum up the deviation, sum of all of these data. So negative 90 plus negative 70 plus negative 50 plus 0 plus 60 plus 150. What's the number of this? So negative 90 minus negative 70, that's negative 160. And then minus 50 is negative 210. And then plus 0 and plus 60 plus 150, that's plus 210. So this is 0. That means deviation 0. So can I use deviation to say a data is good or not? So maybe I say the good means close to, each data is close to the mean. I can't say because the sum of deviation is 0. I can't use the deviation to say the data is close to the mean. So if I give you an example to understand the deviation, let's say for example, a restaurant, I use R represent a restaurant. Restaurant wants to buy a cheese cutting machine. And there are two providers or two factories, A and B, provide the machine. And R doesn't know which one he wants to buy. So he wants to see the data from these two factories. And then the restaurant said, I want the machine can cut the cheese into 1 pound. So that means once the machine cuts the cheese into the cheese wants the machine to cut the cheese into 1 pound. That means the mean should be equals 1. So if the maybe R think if the A factory can cut the cheese, the average is 1, I will buy from the factory A, and the B, if they can cut 1 pound the cheese, I mean the average of the cheese is 1 pound, he will buy from the store B. But the A and B said their average are all 1 pound. So the restaurant doesn't know which one to buy because the A gave the data that is, if the data, the first piece he cuts the cheese is 0.5, second piece is 1.5, and third one he cut 0.3, and the next one is 1.7. The next one is 1. And then if we add up all of these data and divide it by 5, we got the mean equals 1. And the store B said, my machine can cut the first piece is 0.75, and second piece is 1.25. The third piece is 0.9. And the next one is 1.1, and the last one is 1. So as the sum of these 5 data divided by 5 is also 1. So which machine the restaurant should buy from the A store or B? So all of you will think that the restaurant must buy it from the store B. Why? Because 0.75 is close to 1. This data is very close to 1. even the mean is 1. And but you see, the first data is very far from the mean 1, and this one is far from mean 1. This one is far from mean 1. This one is 1. But all of us will choose the second one because make the data more accurate, right? But let's see the deviation, the sum of the deviation. So the deviation for this one is negative 0.5, and then plus next one, this data minus 1 is 0.5, and then plus 0.3 minus 1 is negative 0.7, and then this data minus 1 is 0.7, and 1 minus 1 is 0, and I add them together, that's 0. The deviations, the sum of deviation is 0. And then second data, I have 0.75 minus 1 is negative 0.25. And then at the second data, deviation of second data, that's 1.25 minus 1 is 0.25. And next data, 0.9 minus 1 is negative 0.1. And then plus this data minus 1 is 0.1. And then 1 minus 1 is 0. So I add them. I also have the deviation 0. So from the data, I can't decide which one to buy because they have the same deviation, same mean. But we need to have another definition we call the standard deviation to decide which data is more close to the mean. And this is a very simple question because we have only 5 data for each factory or each store. If we have a lot of data, like 10,000 data, and then you can't see from the data which one is better, is close to the mean, you must to have the standard deviation to help you to decide if, so next one is the standard deviation. If the standard deviation is small enough, that means the data is close to the mean. So the definition of standard deviation is a measure of amount of variation or dispersion of a set of value. How to find the deviation? It equals the square root of the sum of data item minus mean squared minus divided by n minus 1. So let's see the meaning of the sum of the data item minus mean squared. That means the sum is outside, and then that means, so we compute the sum at the last step. That means for each data item minus mean, for example, if I have 1, 2, 3, 4, 5, and then we can find the mean because we have learned the mean. We have found the mean is 3. So the data item, first one is 1 minus 3, and then squared it. And then because the sum means, the sigma means the sum. So add 2 minus 3 squared, and then add 3 minus 3 squared, plus 4 minus 3 squared, plus 5 minus 3 squared. So this part is the top of the fraction, I mean the denominator. That's the sum of data item minus mean squared. And then, so I use square root here. So this is the top divided by n minus 1. N here in this example is 5. So 5 minus 1 is 4. Then we can find the standard deviation of this distribution. So this is a very simple example. And let's see, since we are looking for the standard deviation, we need to know the mean, the n, and all of the data. So let's see the steps to find the deviation. So the first step, find the mean of the data. Yes, we need the mean. Second, find the deviation of each data item from the mean. That means we're looking for this part. So each data item minus mean. And then third step, square each deviation. So like this, when we find the difference between data item and mean, square them. And then fourth step, sum the squared deviations. So add all of these, the previous step together. The fifth, divide the sum in step 4 by n minus 1, where n represents the number of data items. So we got this step. And then last step, just the square root of this value, we got the standard deviation. Actually, if you feel you don't need the 6 steps, maybe you just skip some steps, and then you can find the standard deviation. Because maybe you don't need to list the 6 steps. Maybe you from the first step and jump to the 4th and then jump to the 6th. It's okay because you got the right answer. So find the standard deviation for the group of the data items. So the first step, let's find the mean. Or you can list the formula of the standard deviation. If I use SD represents standard deviation equals the square root. Oh, sorry. The square root of the sum of the data item minus mean squared, and then divided by a minus 1. This is the formula. So the mean, let's see. So how many datas? 1, 2, 3, 4, 5. So 5 datas, and add all of this together. So 23 plus 24 plus 25 plus 26 plus 27. You can use your calculator to find the sum of these. So that should be 25. So the mean is 25. And then we can compute this part. So each data minus 25 and squared it. So 23 minus 25 squared. This is a deviation squared for first item. And add the second, that's 24 minus 25 squared. And then add 25 minus 25 squared plus 26 minus 25 squared plus 27 minus 25 squared. So this is the top part in the square root. Okay, let's see what are these. So negative 23 minus 2 is -2. -2 squared is 4. Plus 24 minus 25 is -1. -1 squared is 1. Plus this is 0. This part is 0. And then 26 minus 25 is 1 squared. And then 27 minus 25 is positive 2. 2 squared is 4, right? 2 squared is 4. So 4 plus 1 plus 1 plus 4, that's 10. So the mean is 10. And what's the next step? Because we have the top, we can say SD equals. So the top is 10. 10 over n minus 1. N is 5 because we have 5 datas. 5 minus 1 is 4. So square root of 10 over 4. That's square root of 5 over 2. And then you can use a calculator. You can have standard deviation is 1.58. Okay, we found the standard deviation for this question. Let's see next one. Next example, find the mean, range, and the standard deviation for the sample A. Sample A is 14, 28, 42, 56, 70, 84, 98. I love these data because it's from the small number to the biggest number. So we don't need to reorder it. If we are looking for a median, or it doesn't ask about median. So never mind. Okay, mean equals the sum of the x over n. So the sum of all of these data, that's 14 plus 28 plus 42 plus 56 plus 70 plus 84 plus 98. So how many data? 1, 2, 3, 4, 5, 6, 7. 7 data. So what is the mean for this one? So that's 56. You can use your calculator to find. So we found the mean. How about the range? Range equals the greatest number minus the smallest number. The greatest one is 98. The smallest is 14. So this one is 84. So this is a range of the data. And how about to find this SD? We have learned that SD equals square root of the sum of data item minus mean. And then we squared it. So first I squared it, and second, so add them together, and then n minus 1. So let's plug in the number in it. You can do them separately. You can compute this part first, and then plug it in the expression. If I just make a very big expression, so I need a long line. The bottom is n minus 1, 7 minus 1 is 6, or I say 7 minus 1. And then the first data is 14. 14 minus mean, 56 squared, plus the second data is 28 minus 56 squared, plus third data is 42 minus 56 squared, plus 56 minus 56 squared, plus 70 minus 56 squared, plus 84 minus 56 squared, plus I have no space, so I wanted to make it smaller and then make them in one line, so you will see it clearly. So first data 14 minus 56 squared, plus second one is 28 minus 56 squared, plus 42 minus 56 squared, and then plus 56 minus 56 squared, plus 70 minus 56 squared, plus 84 minus 56 squared, plus 98 minus 56 squared. We make them in one line. So we can use the calculator to compute this information. And then finally, we will get, so bottom must be 6. And the top one, we should use calculator. So the first one, we just computed for a little bit. So 14 minus 56, that's negative. That's negative 42 squared. And then plus, so 28 minus 56 is negative 28 squared, plus this one as 6 minus 2 is 4. negative 14 squared. And then next one is 0 because 56 minus 56 is 0. 0 squared is 0. Plus 70 minus 56. That's 14 squared. Plus 84 minus 56. So 6 minus 4 minus 6, 8. 28 squared. And then plus 98 minus 56, that's 2, that's 42 squared. And then use a calculator, find the value of these. So you must have 30.24. So the standard deviation is 30.24. I think that's a big standard deviation based on the data. Okay, that's the last question. Okay, I hope you have learned something from this class, because this is the last lecture video for this semester. And if you have any question, please email me and let me know. Also, you can join the meeting and we can discuss about the question. I hope you have a good semester, and hope see you later in following semesters. Okay, have a good one. Bye-bye.